recursive formula of those. A geometric series and then its attendant sequence and then its attendant series are very similar to arithmetic except for the following. They increase or decrease not by a constant amount, that is adding or subtracting the same thing each time. They are multiplied by the same thing each time. So for instance, in this case, we would say this is geometric because each time we're multiplying by 3. And that 3 is the constant ratio, typically written as R, and is found by taking the term, and instead of subtracting the preceding term, we divide by the preceding term. And this is how we can check to see if something is geometric by doing this division. If we get the same thing every time, that's the constant ratio. Typically, we identify these also using the first term, and we'll use a sub 1. Sometimes we'll use g sub 1. G for geometric, obviously. But that's not always the case. A sub n, a sub whatever is often what your book is going to use. So the recursive formula tells us what is happening from one term to the next. To be fully defined, there must be two parts. This is just like in arithmetic. The big difference, well, there's not a big difference here. We must be given the first term. The relationship between the terms is then given. Instead of adding or subtracting, you can see that we're multiplying by the constant ratio. Sometimes we'll write this as R a sub k, same idea. Now I should probably point out at this point, you might be thinking to yourself, wait a second, we've seen something that multiplies every time when there's this constant ratio thing, which means we're multiplying by the same thing. That's exponential. So it turns out where arithmetic end up being linear, geometric end up being code for exponential equations. So for instance, if we're looking at 1, 3, 9, 27, the first thing we want to do is go easy. A sub 1, the first term is 1. That gets us in the door. Always good to define that. And we know that a sub, well, we'll use what the book is going to use. A sub k plus 1 is going to be what? Well, in this particular case, because this looks familiar, doesn't it? Hey, we're multiplying by 3. That's the constant ratio. 3 a sub k. And taken together, this whole thing there would be the geometric, the recursive form of the geometric sequence.